Hey, hello guys, welcome back to my channel Data Science with Gagan. First of all, apology for that delay for this video because of some reasons I couldn't upload videos on data science project. But yes, now I am back. Um, through and I hope through my short videos you guys know what I'm going to share in this video, as I'm not going to share any of the data science project today in my video. Instead of that, I have planned to share an ideal roadmap for data science, because many of my friends used to ask Gagan what to do for data science, what to do in data science, what to do to become a data scientist. So I have decided to come up with this video where I'll be sharing some close steps. So following that steps, you can become, you can get some idea in data science. But I'm not saying following this roadmap you will become a successful data scientist, but yes, it will help you throughout your way to data science. And if you will like this video, then I'll try to come up with another video for advanced roadmap for data science, where I'll cover some advanced topics like GenAI, LLM, and related topics. And before we start, I would like to request you guys just to press bell icon, like button, and subscribe my channel, so it will motivate me to come up with some advanced topics and other videos, so I could help you guys in your way to data science. So here in the screen you can see this is going to be the roadmap in this video for data science, where I have mentioned 4 steps. Step 1, basics and fundamentals. Step 2, mathematics. Step 3, machine learning. Step 4, deep learning. And ahead in this video I'll cover each topic one by one, where I will tell what to learn and what to study for each step, right? So let's start with maths. So here you can see I have mentioned some topics like linear algebra and maths. So let me tell you one example where we can use linear algebra. So we use linear algebra mostly in linear regression, which is a supervised learning algorithm which we use for regression analysis. And then we have probability. So we use probabilities, many algorithms. One of the example of these algorithms is you can say multinomial based algorithms, which is a supervised algorithm for classification purpose. Then we have sets. Then we have vectors and planes. We use vector and planes, while creating SVM algorithm, because which stands for support vector machine. Then we have calculus. Calculus means integration and differential, which we use while creating deep learning algorithms. And then we have trigonometry, like most of the trigonometry we use while creating activation functions in deep learning. And then we have matrix and determinants. The matrix and determinants we use mostly when it comes to image pre-processing and image operations. And then we have some hypothesis testing topics like z test, t test, chi-square test, alpha beta testing. So you should have an idea where to use z test, basically what is z test and why do we use it and when to use it. And then we have another test which is t test. Then what is t test, when do we use it, why do we use it. And then we have chi-square test. Then why do we need it and why to use chi-square test. And then we have alpha beta testing. This is another, like this is the other hypothesis testing. We should have an idea like what is alpha beta testing and for what use cases we can use it, and then why do we use it. Okay, so this is all under the maths. That's we have that we should have an idea what are these topics which can help us to have a great understandings of machine learning algorithms and deep learning algorithms. So let's come to the machine learning part. So here you can see I have mentioned most of the things related to machine learning algorithms. So basically you should know what is machine learning, right? And there are certain types of machine learning, which are supervised learning, unsupervised learning, reinforcement learning. Supervised learning, where we have labeled data which helps the model, Then we have unsupervised learning, where we have unlabeled data, means like where we have any target variable for each row, and on top of that data we used to create model itself, like you can say the customer segmentation things, right? And then we have reinforcement learning. In reinforcement learning, model used to learn itself from the feedback. Yeah. Then when it comes to supervised learning, right, then there we used to have two problems. One is regression, then second we have classification. And for regression problems we have certain algorithms, and for classification we have certain another algorithms, right? Then now let's start with regression, right? So here you can see for regression, we have n types of algorithm, right? First one is linear regression, polynomial regression, OLS regression, regularization. In regularization we have two algorithms, which is L1 and L2, means ridge and lasso. And then we have gradient descent, then we have decision tree regression, then we have quantile regression, then we have stepwise regression. Using stepwise regression, you can start your model from the scratch, means using stepwise regression you can come up with good feature set along with the good model, right? Then we have gradient. Then before starting with gradient boosting, let me tell you, there is concept which is ensembling technique. Ensembling technique means like where multiple model used to work together. And ensemble techniques is of two types. One is bagging and second one is boosting. In bagging, algorithms used to work in parallel, and in boosting it's in a sequential. So then now let's start with gradient boosting, which is a boosting algorithm. Then we have random forest. Random forest is a type of bagging algorithm. Then we have AdaBoost regression, XGBoost regression. Then we have ANN regression, which is artificial neural network regression. So let me tell you, what should you learn about this algorithm? What is this algorithm? What is this algorithm, and how it works? What is the math behind it? Right? If you if there is any assumptions to take care of, then you should know what are those assumptions for that particular algorithm. It's not mandatory that every algorithms needs some assumptions, right? Most of these algorithms have some assumptions, but most of them don't have. Okay, once you are done with this thing, you should know, if you are working for a regression problem, right, then how to evaluate a model that you have created so far on your data. Suppose if you have created a regression model, right, then we have certain evaluation metrics to evaluate your model to identify its accuracy. So we have certain evaluation metrics, which are adjusted R square, MAE, MSE. MAE means mean absolute error, MSE mean squared error. Then we have MAPE, which is mean average percentage error. And then we have Bayes and variance trade-off. These evaluation metrics we generally use to evaluate the regression models. Now let's come to classification models. Then in classification we have a number of algorithms as we had in regression models, like logistic regression, multinomial naive classification, decision tree classification, KNN, which is k nearest neighbor classification, SVM, which is support vector machine classification. Then we have ANN classification. And then we have random forest classification, which is again the part of ensemble technique. Gradient boosting classification, AdaBoost classification, XGBoost classification, right? These are some algorithms for classification purpose. Now for these, you should learn the same things that we had learned for regression models, right? But here, for classification models we have other evaluation metrics other than the regression one, right? And what are those now? Like accuracy score, F1 score, what is precision, recall, AOC, ROC curve, confusion metrics. So these are some evaluation metrics that we generally use to evaluate the classification model, right? So now let's come to unsupervised learning, which is another type of machine learning. as we have two types of problems in supervised, like regression and classification. So similarly we have in unsupervised learning, which are clustering, dimensionality reduction, anomaly detection, and association rule mining. So in clustering means, like, where we used to create clusters, or where we used to group the data on the basis of their similarity. And then we have dimensionality reduction, like, some suppose you have 1,000 columns in your data, right? Then how can we reduce that to n number of columns, right? Which is dimensionality reduction. And then we have anomaly detection. Suppose like an anomaly detection, like, you can say, like, which is anomaly for your data, right? Then how can we do it? How can we identify it, right? And then we have association rule mining, like, suppose if I'm going to market, right? And if I am buying product A, then what are the chances, like, that I will buy product B, which is there beside that product A in the market, right? Which is association rule mining, right? And then, like, in clustering we have multiple algorithms, like k-means clustering, db scan clustering, which is density based clustering. Then we have VIRCH clustering. Then we have hierarchical clustering and spectral clustering. And then we have mean shift. Then we have affinity propagation. Then we have Gaussian mixture. And then for dimensionality reduction, we have PCA, which is principal component analysis algorithm. We have another two algorithms for dimensionality reduction, which are manifold learning and autoencoder, right? Then for anomaly detections, we have three algorithms here, which are isolation forest, local outlier factor, and then we have minimum covariance determinant. And then similarly we have some algorithms for association rule mining. Some, like, one is a priori algorithm. And then we have equivalence class transformation. And then last algorithm, which is FP growth. So these are some algorithms for unsupervised learning, where we have unlabeled data. Okay. And then we have other some topics that we should cover in machine learning, or that we should learn in machine learning. Like, basically these are some challenges, right? Like, what is overfitting, right? And what is underfitting, and then how can we deal with overfitting and underfitting, right? Then we have data leakage. Then what could we do to avoid data leakage? Then we have, like, when we do classification things, right? Then it might be possible your data is imbalance means, like, most of the data is for class 1, but right, but suppose you have 100 rows for in your data, and out of 100 rows you have 98 rows for class 1 and 2 rows for class 2, right? So that is imbalance classification, imbalance data, right? Then how can we do, how can we deal with that problem? Like, there are multiple techniques you can see in the screen. I have mentioned, right, some of them. S mode, which is S mode, then oversampling, undersampling, class width matter, while training the model, right? And like, if you don't want to use any of them, then what evaluation metrics we can use to evaluate that model, right? Then we have different data scales, right? Then like, suppose in your feature, right, one scale is at 1,000, but another one is at zero point 0.0 or 0.01, right? So you can see there is a huge difference between the data scale, right? Then what could we do to deal with it? Then we have encoding. So encoding means, like, you have some categorical data in your data, right? Then and we can't directly feed that data to the machine, right? Then what can we do, right? Then we have encoding techniques, like, which are label encoder, one hot encoder, ordinal encoder. And then this is the major problem, right, that you might face most of the time, which is outliers, right? Then how can we use outliers? Outliers means, like, suppose in one data point, right, most of the data is at the same scale, but out of that data, one data point is at the higher scale. Suppose your data scale is around 0 to 2, but at the same time, what you see, like, one of the data point is having 1,000 scale, which is an outlier for your data, right? Now, once you identify your outlier, then how can you deal with it? Then we have multi-collinearity, right? Because some of the algorithms like, have assumption, like, we should not have the multi-collinearity in our data. Then how can we deal with it? right? So these are the major things that you should learn, in machine learning. Now let's jump to deep learning part, which is very interesting. So let's jump to it. So let's quickly start with deep learning. Basically, deep learning is a subset of machine learning, or you can say it's a part of machine learning only, where we used to make machine to think like human being, right? That's why here everything is related to neural network. And we mostly use deep learning for text analytics or speech data and object detection cases, right? And we have some dedicated algorithms for each use case. Like we have some dedicated algorithms for text analytics and speech data, like RNN, which is recurrent neural network, ANN, which is artificial neural network. Then we have LSTM, long short term memory network, like which is dedicated for sequential data analysis, like text analytics and speech data. And then we have so many algorithms which are dedicated for object detections, like CNN, which is convolutional neural network. Then we have RCNN, fast RCNN, faster RCNN, where RCNN stands for region based CNN, right? Basically, these are the variants of CNN. And then we have YOLO, which is you look only once, which which is there with the multiple variants, like YOLO V1, YOLO V2, YOLO V5, YOLO V10. Like there we have 10 models for YOLO V10, YOLO V. Then we have Detectron, which is a model from Facebook. We have multiple variants for Detectron as well. And then we have ResNet, which is residual network. And then we have VGG model, which stands for Visual Geometry Group. Again, we have multiple variants for VGG, and every model is having their different accuracy, like different weights. And then we have GAN, which is Generative Adversarial Network, which is used to create, which is used to create, synthetic data out of your current data, right? Suppose if I am having some image, right, then how, like doing multiple changes to image and then create another data, right? Which we can use, which we can do using GAN, sorry. And then we have SST, which is single shot detector. And all of these algorithms we can use for object detection purpose, right? And then again, like the things which comes up, right? Like what should we learn about these algorithms, right? So like the main thing, like what is that algorithm and how it works and how maths is working around it, right? And then if you have created one model, then how can you evaluate that model up, right? And then how can we, and the main thing is, right, like to identify, like where to use which algorithm, right? And then these are some algorithms, like these are some basic algorithms that you should know about, or you are aware of it, right? Like there are other advanced algorithms out there in the market apart from these algorithms which is there in this sheet, right? I'll once like if you will like this video, then I'll also come up with all those algorithms in my next video. Okay. And then there are some terminologies, or you can say there are other some concepts which is related, which is there for deep learning, like forward propagation, backward propagation. Basically, like when, like forward propagation means, like uh, to move in the forward direction from input layer to output layer. And then we have backward propagation, where we generally update the weight, or we where we generally optimize the weight so we can have an accurate output from the model or from the algorithm, right? And then we have activation functions, we basically use activation functions to have a non linearity in the output, okay? And then like there are multiple kinds of activation functions, like softmax, relu, leaky relu, 10h, swiglu. Then you should be aware of it, like when to use which algorithm, which activation functions, right? Right. And then we have pooling me, there again we have multiple kinds of poolings, like max pooling and average pooling. So you should be aware of it, like when we should use pooling, right? When it comes to CNN network, right? Then there we use pooling layer, right? And then we have strides, when it comes to object detection, right? Then there are strides, padding, right? Then again, right, optimization, right? As I told, right, in propagation we perform optimization things, right? So we can have optimized fit, so we can have accurate output from the model. So for that purpose we have some optimizers as well. So there are multiple optimizers, like gradient descent. Gradient descent comes in three variants: batch, mini batch, and stochastic. And then we have, atom optimizer, then we have ADA grad, then we have RMS prop, then we have ADA delta. So these are the optimizer that we can use, while doing back propagation. Then you should know what is, multi-layer perceptron, dropout layer, hidden layer, bounding box. You should be you should know about the things that you should know about dropout layer is, like, when to use dropout layer, right? And why do we use, dropout layer? And then we have some many multiple things, related to object detections or image things, like which are bounding box, aspect ratio, right? IOU, which is intersection over union. Then at anchor box. So you should be know of it, like, what are these things. Then we have some losses, right? When we do classification, yeah, right, then we should have we have some losses there, which are entropy loss, cross entropy loss. So you should know, like, when to use which loss. Then we have data augmentation, batch normalization, vanishing gradient, and exploding gradient. So there, when we do back propagation, so there could be two problem that you can face, which are vanishing gradient and exploding gradient. So you should have an idea, like, how to deal with them, right? Using, like, which activation function we can use, so we can avoid these problems. Then we have some other terminologies like epochs, hyperparameter, transfer learning, so, right? So you must be know what are these things in deep learning. So, like, once you will learn all these things, your concepts will get clear for deep learning. And similarly, the concepts we have in machine learning, if you will learn all these concepts, then you will get clear with the concepts of machine learning, like, how these algorithms works and how maths, works around it. So yes, guys, this is all about this video, where we saw, like, what are the concepts that we should learn or that we should clear, so we can have a clear cut idea of machine learning and deep learning algorithms. If you will like this video, then I'll come up with, some advanced topics, as I mentioned in this video.
To keep me motivated for more videos on data science projects, please do like and subscribe. And please do not forget to press bell icon for notification of new project